My name is Juan Saucedo Ochoa, and today I will be talking to you about the discounted cash flow model and its uncertainties. Let's get started. So to begin with a historical overview, in the 18th century, the main valuation methods were the dividend yield and book value methods. In the 19th century, cash flow criteria were developed to value non-financial assets like railroad projects, which required large initial capital expenditures. In the 20th century, the DCF model became significantly important during the tech bubble of the 1990s for its ability to value complex technology firms that other valuation models simply couldn't do accurately. Today, the DCF model is extensively used in finance due to its ability to estimate the intrinsic value of an asset independently of external market factors, especially in mergers and acquisition scenarios. So, what is a discounted cash flow model and how does it work? So the discounted cash flow model asserts that the fair market value of a firm is the present value of its future cash flows. Essentially, we project all future cash flows given certain assumptions, and we discount these future cash flows through a discount rate called the weighted average cost of capital. After discounting, we sum up the present value of all future cash flows, giving us an enterprise value. From there, we can work backwards to estimate the implied per share value, aka the fair equity asset value. So the expected accuracy of the DCF. So importantly, the DCF does not aim to predict current share prices. Rather, it estimates a range of fair values for equity assets. This range is derived using sensitivity analysis, adjusting variables like WACC and exit multiples to see how these adjustments impact the implied fair equity value. So if we look on the left-hand table, we can see a range of WACC and a range of exit multiples. And this gives us a range of outcomes or outputs, such as an enterprise value, from which we can derive the fair implied per share value. So the sensitivity analysis is visualized through football field graphs to communicate how different inputs affect valuations. As seen in the bottom column of this graph, we see a valuation range from a DCF model with the WACC range from 10.5 to 11.5% and an exit multiple range from 7 times to 8 times. So this is the valuation range that we get from the DCF, and then we compare it with other valuation models and to arrive at a final valuation range. So estimates of accuracy. Accuracy in the discounted cash flow model is quantified by the VP ratio, MAP, and PE ratio. And these accuracy metrics evaluate how closely the model's fair value estimates align with current market share prices and the size and direction of pricing errors. For the VP ratio, values closer to 1 imply greater accuracy, while for the MAP, smaller values imply greater accuracy. So the discounted cash flow model tends to not be evaluated for accuracy individually. Rather, it is compared to other valuation models, such as the dividend discount model. Alfredson and Lehman found that the discounted cash flow model performed the worst compared to other valuation models, as seen by its higher VP ratio and MAP. So if we look at this table, we can see that in comparison to 3 other valuation models, the DCF has a higher average VP ratio and a higher MAP ratio as well, indicating lower accuracy than the lower models and worse performance. So other authors found that the discounted cash flow model performed significantly worse than the dividend discount model, with the DCF's MAP being almost 5 times as high. Therefore, this is evidence that the DCF model fails to be accurate in comparison to other models. So, the source of uncertainty in the DCF model lies in its assumptions, which are determined through historical data. Hence, these assumptions, aka inputs, fail to account for their inherent uncertainty and whether or not their values will be realized in the future. Put simply, uncertain inputs produce uncertain outputs. To show how these assumptions have impacts throughout the entirety of the DCF model, let's look at an actual example of a DCF. To inspect them more closely, in green, I have highlighted the assumptions which are presumed to be constant in the model, such as margins and WACC. If we look more closely, highlighted in green are all the cash flow projections which are impacted by these uncertain assumptions. These assumptions impact nearly every item in the model, such as exit multiple, with the discount rate and the exit multiple, aka the terminal value, having the greatest effect on the model output and its uncertainty. Despite its widespread use, the inherent uncertainties of the DCF model tend to not be communicated effectively to the public. Discussions with the public involve learning how the model works, but not its deficiencies. Therefore, it is critical that we begin to make progress in communicating the uncertainty of the DCF model to the public. Thank you.